Okay, good day, dear students. Now we'll continue to discuss on the embodiment design. Now, today we are going to continue on the configuration design. So this is the preliminary selection of materials and manufacturing processes, modeling, and sizing of parts. So here we have discussed already the product architecture, and now so we are in the configuration design. So the design of a special purpose parts and the selection of standard parts, like components like pumps or motors, no? So this is where you decide on the specific parts, no, sa imong gamiton. For example, if you want to decide on what kind of transmission system that you are going to use, no? Either you decide on belt and pulley, or you decide on chain and sprocket, or you design you want to have a transmission system made of a gearbox or gear systems, you know? So and after the configuration design, we'll be taking up the parametric design. Okay, so in configuration design, this is where we establish the shape and general dimensions of a components, no? So a component is used in the generic sense to include special purpose parts or standard parts and standard assemblies, no? So yung component, this is kining mga parts nga which are already standard or standard assemblies or special purpose parts, no? We have here part. A part is a designed object that has no assembly operations in its manufacture. So a part is characterized by its geometric features such as holes, slots, walls, ribs, projections, fillets, and chamfers. So the arrangement of features includes both the location and orientation of the geometric features. So part more specific na gyud na siya nga kanang part, no? It is ang component is made of several parts. So sample is one here. This is 4 possible configurations of features of a right angle bracket. So a bracket is a part, no? Part na siya, but daghan siya ways in which to make the bracket. So these are the different configurations, no? You can make a bracket made from bent flat plate, no? So flat plate na siya gi-bent into 90 degrees, so mahimo na siyang bracket, no? So or you can make a bracket from machine from a solid block, no? So looking at it as a cube, i-cube na siya, niya gi-cut, no? Dinhing na pita, gi-machine. So this is another way of making the bracket. This third one is a bracket welded from 3 pieces, no? So we have kining a piece, this is a square plate, and this is another square plate, and we have this triangular plate, no? So they weld it, weld making a bracket with support, no? And the last one is making a bracket made from casted, no? Meaning to say, mo ingon tag-cast, kana bang naa siya hulmaan, no? Metal, gitunaw ang metal, then gi-pour into the mold, and to form this kind of bracket. So it depends, no? In the configuration design, you can specify what form or what shape or what how are you going to manufacture or make it, no? So that is the configuration design. Now, a standard part is one that has a generic function and is manufactured routinely without regard to a particular product. Examples are bolts, washers, rivets, and mga I-beams, no? Kini mga angular bars or square bars, no? These are standard part, no? May unta pulley, standard na siya na A-type, na B-type, na C-type. So na ay flat belt, no? So these are mga standard mga parts. You can just buy it in a commercial mga store or kining mga namaligya og mga kining hardware. Okay, so a special purpose part is designed and manufactured for a specific purpose in a specific product line. Okay, so kining mga special purpose part, no? For example, kining mayong sa may mga specific part nga para ra gyud sa ana. For example, kining cover sa Honda XRM, ang kanang iyang murag plastic, no? Kining iyang fender o kining iyang murag tapaludo sa likod, no? So it's specific only for XRM, no? So these are special purpose part. And we have sub-assembly is an assembly that is included within another assembly or sub-assembly. So example kaning mga carburetor sa engine. So this is a sub-assembly of the engine. So kaya ang engine di man mo function po dili sa mo under without the carburetor, no? So ang carburetor mo na siya ang mo control sa amount of air nga musud dito sa engine o niya magsagol sa fuel, no? And then we have a standard assembly. Standard assembly is an assembly or sub-assembly that has a generic function and is manufactured routinely. So examples are electric motors, pumps, gearboxes, no? So these are mga standard assembly. No, so which means that you can just specify mo specify lang for example electric motor. You can just specify what horsepower you need or unsa nga kanang single phase ba, three phase ba na siya, no? So induction type ba, so you can because these are kaning routinely manufactured, no? So nanana siya sa market. Now, steps in making configuration design. So you have to review the product design specification and any specifications developed for the particular sub-assembly to which the component belongs, no? So i-review ang product design specification and specification developed for the particular sub-assembly kung to which the component belongs. Sa asa man na siya nga component, no? So you have to review mo fit ba na siya dito, is the material you are going to manufacture heat resistant ba na, does it need to be durable, does it need to be resistant to salt. So ingon na, no? Then number 2, establish the spatial or spatial constraints or ang space niya, how big is the space available. So you have to think on for example madaot siya, or how are you going to remove that part, no? Na ba siya, accessible ba siya, no? So what are the constraints that pertain to the product or the assembly being designed? Unsay mga constraints anang part din ha, no? Then create and refine the interfaces or connections between the components, no? So unsa man ang connections between the components, interfaces, does it need to be sealed nga, for example mayong kaning mga connectors sa kanang pipes, no? When you connect a pipe, it should have the interfaces nga sirado gyud siya, otherwise na ay leakage, no? And that's why you have to specify unsa ka daghan ang iyang kuan thread, then unsa ang iyang clearance or unsa ang mga ngipon niya, is it coarse, is it fine. So these are the example, no, in you have to refine or kining sa interfaces. So does it need to have for example a gasket in order nga sirado gid siya? So unsa man ang interfaces, smooth ba siya ang pag-touch between the surfaces, is it smooth, is it rough, no? So these are the things that you have to consider. Number 4 is answer the following questions. Can the part be eliminated or combined with another part? So kani bang part pwede ba ni siya tanggalon, and or can this be combined with another part, no? These questions leads to making it simple or making the component or part kuan kanang cheaper, no? So how are you going to make it na simplify siya or making it cost effective, no? Then number 5, can a standard part or a sub-assembly be used? While a standard part is generally less costly than a special purpose part, two standard parts may not be less costly than one special purpose part that replaces them, no? So for example, kung ang sub-assembly pwede ba na ilisan og standard part, or can we make a special purpose part if the special purpose part will offset the cost of standard parts nga duha ka buok na standard parts nga mo puli ana niya, then better to make a special purpose part, no, if that is cheaper, no? Kung pwede raman siya himuon nga usa na lang, no, instead of two standard parts, no? Okay, so for example kaning maghimo ka og transmission, instead of having four ka mga kuan kining combination of belt and pulley in order to reduce the speed. So what if you just replace it by one gearbox, no, gearbox system, which is no, imo na lang isalpak dito na. So which is cheaper, no? So that is what you are going to consider in making the configuration design. Okay, for example is pen light, no, component decomposition for configuration design of a pen light. Now ang pen light na asay bulb, na asay battery, na asay body, na asay screw cap, no? So so these are arranged in a physical building blocks, no, na so separate ang bulb, separate ang battery, separate ang body, separate ang screw cap. So ang bulb nasa glass lens, nasa filament, nasa base, no? So battery nasa anode, na cathode, na electrolyte, na plastic cover, and body i-attach po ang switch, i-attach po ang case, i-attach po ang spring, then na ay screw cap, no, ang takob, no? So what if ang switch i-integrate lang sa iya case, or ang spring naka-attach lang sa body, no? Unya, what if ang wad-o na lang ng screw cap, no? You can replace it sa screw cap. How are you going to replace the screw cap? Integrate lang na mo sa body, no? So that is how you are going to think on the configuration design, no? How can you make it simpler, no? So okay, so for example in this case the configuration problem nimo, you have the special purpose part, no? Then required dimensions, na geometric features, type number 1, number, the arrangement of features, the relative dimensions, the design variable, parameter list, no? So out from these geometric features, you can select, no? For example, in the geometric features, unsa may ang iyang kuan, walls, ribs ba, projections ba, fillets, ang iyang it could be rounds, it could be bosses, it could be cylinders, tubes. So these are mga features in the kuan special purpose part nga maybe you can make a decisions, no, in the configurations in your design. So imo ba nang i-chamfers, no? So it also very affects the features or the performance or the overall looks or features or the artistry of the design, no? So kung ang imong maybe ang imong pin light will be looking like a spear, no? So it affects the overall look of the product, no? Okay, so here are the three considerations in making the interrelations between function and form, and in turn their dependence on the material and method of production. Now, so the most important is the function, no? So all kaning form, it should support the function, and the product manufacture assembly should support the function, and the material would also support the function. Ang material should support the form, and material should support the production or manufacture assembly, and also support the form, no? So naa siya interrelationship, no? But the center of this is the function. So you have to really think on the function, dili siya maapektaran with your configuration design, no? So in the form, you have to think on the constraints. Unsa man mga constraints ang iyang spatial or the space, no? Ma-affect niya. For example, if your space is too small, unya mo gamit ka og material nga not too strong, it really affects the function, no? So using that constraints, you have to look into that type of material. Kung yung ka nga, instead of using plastic too weak raman siya, then maybe you use material that is stronger, maybe steel, no? And then interfaces, ang iyang mga parts nga nag-abot, no? And then components, unsang mga components nga naka-connect niya na nga mga assembly or part. So there should have interrelationship between material, the form, and the production or manufacture assembly. Now, example here, no, this is a specific part. No, this is the progression of a design configuration from a rough sketch to a 3D computer model to a detailed 3-view engineering drawing. So gikan sa A, makita nato din ang detail, no, sa part. So first is that you have to sketch unsa may itsura sa imong specific part, sa unsa man ay porma niya. Then you can make it in detail, no, with all the dimensions, and then the isometric figure or drawing of that part. Okay, so generating alternative configurations. So images that comes to a designer's mind when making a design of a bolted connection. So this is the bolted connection, no? So bolted connection, you can have different ideas in your configuration design, no? You may start with various bolt connection. Ingon ani ba nga connection ang imo nga um, or connection nga na usarang ka screw diri, ang diri could be welded, no, or you can have a bolt system nga naingon ani locking, no, or it can be ang iya pud mga how you are going to treat the corner. So these are mga specific questions that you have to answer. You have to think on the space for assembly. Sayon na ba na siya i-maneuver kung hugtan, are you going to use open range, or are you going to use kaning allen range, no? Then how are you going to relate this with other parts? Saan man nimo, for example, kung metal ang diri sa pikas and you wanted to have a very tight nga connection nga dili siya masudlan og tubig, so you have to think of that. Then how are you going to prepare a hole? Is it by angle? Is it by directly 90 degrees or 180 degrees? How are you finish it chamfering, no? Do you chamfer it by an angle, or you want to chamfer it by a conical form? And how are you going to put in the thread? By tapping, or what? Does it, you want it a plain or wala siya thread? How are you going to bore it? No? I-bore ba na nimo by conical or by cylindrical? How is the flow of force, no? So these are the questions you have to answer. Or in situation of contact, how are you going to fit it? Is it by kaning mga grooves, or are you going to have teeth, no, or just plain smooth, no? So how are you going to represent the shapes? So these are mga alternative configuration in making your design. Now, patching and refining activities. Kining mga patching is mga kuan lang, mga patch, no, just like magtapa ka og kuan gisi nga sinina, it's patching, you know. Substituting looks for other concepts, components, or features that will work in place of the current idea. So substituting, so maybe you're looking for other technique or other ways to, or concept, no, kana ra nga portion nga kaning imong gi work into nga to make it more efficient, no. Because in a machine na ay mga parts nga really sensitive, no, nga you really consider it very important, kay otherwise kung dili na siya ma-address, no, that is the cause of failure na dili siya mag-operate. Then combining aims to make one component replace multiple components or serve multiple functions, no. So that is way of simplifying. So maybe you combine 2 or 3 parts, no, into one, so you make your own special purpose nga part or assembly, no, in order to replace that tulo ka mga items or components. Then composing is the opposite approach from combining. So here okay, here in the decomposing, this is the opposite approach from combining, no. So from one kanang one big assembly, maybe in here you have to bungkagon na nimo or decompose, no, make it into from one assembly himo na simong tulo ka parts, no. This is also one way of simplifying in order nga kung specific part ra nga madaot kadto ray ilisan, no, not all the whole assembly. Magnifying involves making some feature of a component larger relative to adjacent components. No? So maybe this is one way of making the part stronger or durable by making it big or magnifying, no? Instead of replacing it with a kind of material nga too expensive, you just have to make it bigger, no, so then minifying involves making some feature of a component smaller. For example, kung kana nga part dili gyud na siya nag function o kuan kining support o load, so you can reduce it to make it smaller, no. Then rearranging involves reconfiguring the components or their features, no. So rearrange, no, thinking on making the operation simpler, no. For example, ang switch in this nga layo to ang sa likod, you can transfer it to make it in front, no, kay to access it easily, no. So just a matter of rearranging. Now, best practices for configuration design. Number 1 is clarity of function, no. It pertains to an unambiguous relationship between the various functions and the appropriate inputs and outputs of energy, material, and information flow. So naa-adjoy clarity of function. So dapat ang mga parts na agi kaugalingon siyang mga functions, no. Importante nga main function, no. Maybe na say tulo pat ka functions, but naagid siya main function nga iyang gi-suportahan, no. Then simplicity, it refers to a design that is not complex and is easily understood and readily produced. One way to minimize information content is to reduce the number and complexity of the components, no. So the best design, take note that the best design is the simplest design, no. Mas simple ang design and then it functions the objective purpose. That is the best design, no, because simplicity reduces the cost and it also make the things function easily, no. Then number 3 is safety. Safety should be guaranteed by direct design, not by secondary methods such as guards or warning labels, no. So safety is very important, and that is one of the requirements, no, in qualifying for the quality of the product is the safety. So safety should be guaranteed not by secondary methods, no, such as putting guards or making warning labels. So it should be there should be no rotating or no moving parts, no, that is accessible by hands, no. Then number 4, minimal impact on the environment is of growing importance and should be listed as a fourth basic guideline. So usa po ni karon nga people are looking into the importance of the environment, no, nga dapat ang usa sa mga consideration nato is the impact to the government environment. So here you have to use materials that kanang biodegradable. So usa na sa mga applications impact to the environment. So you should not use materials that is difficult to degrade, or once it is thrown in the field will take 100 to 200 years in order to degrade, no. So the in now is to use mga environmentally friendly materials. Okay, so that I think that ends my presentation.